Hey everyone, and welcome. Today we are going to tackle one of the absolute cornerstones of programming, inheritance. It's this super powerful idea that lets developers build massive, complicated software without going crazy. And the best way to get your head around it? Just think of it like a family tree. So let's dive in.
All right, first things first, let's just ask the big question. Think about the games you play, the apps on your phone, all this incredibly complex software. How on earth do people build this stuff? They're not really typing out every single line of code for every little feature over and over and over again, are they? There's got to be a smarter way to do it.
And you'd be right, there absolutely is. The answer is this really elegant idea that programmers basically borrowed straight from nature, from the way we pass down traits through generations. It's called inheritance, and it's all about building on top of work that's already been done.
Okay, so let's get down to brass tacks. What are we actually talking about when we say inheritance in code? Well, it all boils down to this really simple idea, the parent-child principle.
At its absolute core, inheritance is just this. It's the process of creating a brand new class by grabbing and reusing all the properties and behaviors from a class that already exists. The big ideas here, the ones you really need to remember, are reusing and building on top of. It's the ultimate programmer's mantra of don't reinvent the wheel.
Now, when you start learning about this, you're going to hear a few different terms, but don't let them throw you off. There are two main players here. On one side, you have the parent class. Sometimes people call it the base class or the superclass. On the other side, you've got the child class, which you'll also hear called the derived class or subclass. They all mean the exact same thing. One class is the blueprint, and the other one gets a copy of that blueprint to start with. Simple as that.
Okay, that makes sense. But why? Why even bother with this? What huge problem were programmers facing that made them come up with this whole inheritance idea in the first place? Let's talk about the why.
So you have to imagine life before inheritance. Programmers were constantly rewriting very similar chunks of code all over the place. It was a mess. Inheritance just completely changed the game. Suddenly, code became reusable. And when that happens, your programs get way shorter and much cleaner. You can put all your common stuff in one central place, which, let me tell you, makes fixing things a dream. If you find a bug in the parent class, you fix it once, and boom, that fix automatically trickles down to all the children. It's just so much more efficient.
This quote really just nails it, doesn't it? The whole mindset shifted. It's not about rewriting anymore, it's about reusing. That right there is the soul of inheritance.
Now, just like a real family tree isn't always a straight line, inheritance in programming has different shapes and structures too. It is definitely not a one-size-fits-all kind of deal. In fact, there are 5 main types that pretty much cover everything you'll see out there.
First up, we've got the most common and the easiest one to understand. Single inheritance. It's a straight-up one-to-one relationship. One parent, one child. Think about it like this. You have a general car class, right? It's got wheels, an engine, seats, all that basic car stuff. Well, an electric car is a type of car, so it can inherit all of that, and then just add its own special thing, like a giant battery. All right, next is multi-level inheritance. This is literally like a chain of generations. You have a child class that inherits from a parent, but then that child becomes a parent to another class. The classic example is perfect for this. A dog inherits from mammal, but wait, the mammal class itself inherits from the even more general animal class. So what does that mean? It means the dog class gets traits passed down from both its parent and its grandparent.
Then you have what's called hierarchical inheritance. For this one, picture one parent with a bunch of different kids. A single parent class is the foundation for a whole bunch of child classes. So you might have a generic vehicle class, and from that one parent you could create a car, a bike, and a truck. They all share that core vehicle DNA, they all move, but each sibling gets to be its own special thing.
Okay, now things get a little more interesting with multiple inheritance. This is where a single child class can inherit from more than one parent at the same time. Imagine you're building a smart device. It needs to do phone stuff, but it also needs to do camera stuff. With multiple inheritance, it could inherit from both a phone class and a camera class and get all that functionality combined. Now this is super powerful, but it can also get complicated, which is why some programming languages, like Java, actually don't allow it. But others, like Python, say, yeah, bring it on.
And last but not least, we've got hybrid inheritance. And honestly, this isn't really a new type so much as it's a mix and match of all the others. You might have a big system that uses hierarchical inheritance here and multiple inheritance there. Real software is messy, So developers often have to blend these patterns together to make things work.
So a child gets all these traits from its parent, but what if it wants to do things a little differently? Does it have to follow the parent's rules exactly? Nope. Inheritance is about adaptation, not just blind copying. And that brings us to this really cool idea called method overriding. Let's go back to our animal example. The parent animal class might have a function called sound that just says, makes a general sound. But its child, the dog class, can provide its own special version of that exact same function. So when you tell a dog object to use its sound function, it doesn't make a general sound, it barks. The child has overridden or replaced the parent's default behavior with its own. Pretty cool, right?
Now, I know this can all feel a little bit abstract, like it's just for programmers. But the truth is, you are interacting with stuff built on inheritance every single day. Let's take a look at where this pops up in the real world.
Think about game development. You might have a basic player class. From that, a warrior class inherits, getting all the player stuff. And then an even more specialized knight class can inherit from the warrior. Or how about banking systems? A savings account is really just a special version of a generic account. And even the buttons on your screen, that fancy icon button with a picture on it, it's just a special kind of a plain old button. It's literally everywhere once you start looking for it.
So it's pretty clear inheritance is a hugely powerful tool. It's fundamental. But, like any powerful tool, you've got to use it carefully. It isn't always the perfect solution for every single problem. So let's weigh the pros and the cons.
On the one hand, the good stuff is obvious. You get reusability, which means less code, easier updates, and a nice logical structure. But there's a flip side. Inheritance can sometimes make your designs really complicated and hard to follow. And its greatest strength, that super tight connection between a parent and its children, is also its biggest risk. A tiny change or a bug in the parent class can instantly cascade down and break all of its children, sometimes in ways you'd never expect. It's a double-edged sword.
And all of that leads to this really key piece of wisdom for any developer. Just because you can use inheritance doesn't always mean you should. A good developer knows when it's the right tool for the job and when another approach might actually be simpler and safer. It's all about making smart choices.
So I'll leave you with this final thought to chew on. Inheritance is all about building on the past, right? It lets us stand on the shoulders of code that's already been written. But that raises a really important question. What happens when the foundation you're building on is flawed?